All right, well, in section 5.1, welcome back. We'll take a look at functions and function notation. And here's our objectives to understand that functions are relationship, definition of the independent and dependent variable, domain range, and then a little bit of function notation. So, what is a function, first of all? Function is just a relationship between two variables, but specifically in which there's only for every input, or x value we like to call it, there's only one output. So for every x, there's only one y. Is a requirement to be a function. For every input, for something we put in, there's only one output for it. And the independent variable is often described as the input. And we can assign any appropriate value we wish to this variable. The dependent variable is what we get as the output. Once we put the input in, the dependent variable is the output. So let's go ahead and take a look at an example here with this. So here we've got the formula, the area. Remember, area of a circle. So how much that encompasses, right? The area of a circle is pi times the radius squared. So the independent variable is the r radius. That's the independent variable, or the input. And the dependent variable, so the area of the circle depends on, or the area is dependent on how big the radius is. So the dependent variable, or the output, is the area. Right? So for example, if we have just a little radius of, say, 3 inches, 3 is our radius, then 3 squared is 9 times pi, whatever 9 times 3.14 is. Punch that in, go 9 times pi. In fact, you know what, let me pull it up with decimals here. Come on. So we have our area is 9 times pi. Looks like we get 28.27433. Now, if our radius instead, and that's the area, right? That's how much, like if we were to color that in, how much square inches that would be. Now, if our radius was instead of 3 inches, let's say we had a little bigger radius of maybe 5 inches, now our area, pi times the radius, 5 inches. So we got 5 times 5, we got 25 pi square inches. And then I punch in 25 pi, and I get, so 25 times 3.14, you again use that pi button, 78.53981.634 square inches. So a much bigger area, right? So the area is the dependent variable. It depends on what you put in for your radius, right? So again, the input's the radius, the output is the dependent variable. Now, function notation. So function notation, so for example, if you have y equals 2x plus 3, x is the input, or the independent variable. Y, whatever you put in for x, will spit out some sort of y as your output or dependent variable. Okay, and y in function notation, we're going to call this f of x. F of x. So f of x is a nickname for y, and that's your function notation. So for example, on this first one here, you have y equals negative 3x squared minus 2x. If you put this into a function notation, you could write this as f of x is negative 3x squared minus 2x. And then you could find different values for that. For example, you could find f of 2. And that's saying put 2 in for x and find the functional value, find the y value. So 2 squared is 4. We have 2 times 2 minus 4. So we got negative 12 minus 4. We got negative 16. So f of 2 is negative 16. This is again saying, let me go over here. The functional value, the y value, when x is 2, is negative 16. Okay. Now let's use function notation for the next one here. P equals 13 plus r. So you could write this as f of r. F of r just replaces the p. It's 13 plus r. You could find the value for r, right? Value for p. You could also use, if you don't want to use f, you could use p of r equals 13 plus r and so on. Let's go ahead and evaluate some functions here. So this first one, we have f of x. Again, f of x is just a nickname for y. We can find f of 0. So again, this is saying find y when x is 0. Find the functional value if x is 0. So let's let x be 0. 0 squared is 0. 3 times 0 is 0. And 0 minus 2 is negative 2. So I have f of 0 is negative 2. And then, so that's f of 0. Now let's find f of 1/2 as well. So f of x is 3x squared minus 2. F of 1/2. 3 times 1/2 squared minus 2. Well, 1/2 times 1/2, I'll write it out, is 1 times 1 is 1, 2 times 2 is 4. Now we've got 3 over 1 times 1 over 4. So we've got 3/4 minus 2. Let me bring this up here. Minus 2. And of course I got to get a common denominator here. So this is 2 over 1. Get a common denominator of 4. So I've got 3/4 minus 8/4. 3 minus 8 is negative 5 all over 4. That's f of 1/2. It's negative 5/4. Alright, and then that last one, f of negative 2. Again, f of x is 3x squared minus 2. F of negative 2 would be 3 times negative 2 squared minus 2. So negative 2 times negative 2 is 4. 12 minus 2 is 10. So f of negative 2 is 10. In other words, the y value is 10 when x is negative 2. Okay. All right, the next one, the second one, we got f of t now. So the input is t. 3t minus t cubed. And I'm finding f of 1. Find the functional value when t is 1. Three times 1 is 3 minus 1 times 1 times 1 is 1. 1 times that 3 in front, 3. So we got 3 minus 3 is 0. So it looks like f of 1 there is 0. Oh my gosh, I just realized I wrote that wrong. Whoops, that's 3t minus t cubed. That's not supposed to be there. Let me erase that. That's gone, that's gone. Sorry about that. That is actually 1 times 1 times 1 is 1. 3 minus 1 is 2. There we go. Sorry about that. All right, let's do that next one here. F of t, 3t minus t cubed. Let's find f of negative 2. So 3 times negative 2 minus negative 2 cubed. Well, negative 2 times negative 2 times negative 2 is a negative 8. So we get negative 6 plus 8, which is 2. And let's do this third one now. All right, this last one now, we've got h of v equals v plus 1 over v, and we're going to find, let's find h of negative 3 first. So I get negative 3 plus 1 over negative 3, which is negative 3. I'm going to take that up to the top, so negative 1/3, or negative 3 minus 1/3. So h of negative 3 equals negative 3 over 1 minus 1 over 3. Get a common denominator of 3. So I got negative 9/3 minus 1/3. Negative 9 minus 1, negative 10/3. That's h of negative 3. Now let's do that second one. H of v equals v plus 1 over v. Let's find h of 0. So 0 plus 1 divided by 0. Well, you can't do that. So this is undefined, or no solution. Let's do that third one. H of v equals v plus 1 over v. And let's find h of a. So now we're just plugging a in. So we got a plus 1 over a. Or if you want to get a common denominator, this is a over 1 plus 1 over a. If I get a common denominator, I got to give this an a. So I'd have a squared plus 1 all over a. That's another way to write that. Either of those works. Okay. Well, this section is, we're going to take a look at finding the domain and range. The domain is the set of all input values, or the set of all x values that it could encompass, and the range is the set of all y values. So let's look at this first one here. F of x is the square root of x minus 3. Another way to say that is y is the square root of x minus 3. Well, if you think about the square root function for a minute, I can take like the square root of 0. That's 0, that's fine. I could take the square root of 1, that's fine. Square root of 2, I don't know what that is, but it's square root of 2. I keep going. Square root of 2 is like 1.4 some. Square root of 3 is like 1.7-ish or something like that. Anyway, square root of 4 is 2, and so on, right? So I can plug in all these values for underneath the radical as long as they're greater than 0. But if you notice, if I plug in square root of negative 1 in my calculator, I'm going to get like error. I can't do that. So I cannot have underneath the radical, I can't be anything less than 0. I can't have negatives underneath. So when you see a square root, what you want to do is you want to take what's ever underneath, and for your domain, you just want to say, that's got to be greater than or equal to 0. And then you want to solve for x. So x has got to be greater than or equal to 3. So that's your domain. And then you can say, so you can say it like this, x such that x is greater than or equal to 3. And that's one way to say, to write your domain. So if you think about like what x values can be, this is saying x can be 3 or bigger. So if I'm checking, here's my original function, square root of x minus 3. So I can plug 3 in for x, and I get square root of 0, which is 0. Or something any bigger, like I could plug 4 in for x, and so on. But I can't throw anything less than. So for example, if I put 2 in, I can't do that, right? So that's why it's saying it's got to be greater than or equal to 3. Similarly, for this next one, we got square root of 2x plus 5. So I say, well, that 2x plus 5, let me erase this stuff real quick. Here's my function, square root of 2x plus 5. find the domain. So I just say, well, the domain, the radicand, in other words, the stuff underneath the radical, this has got to be greater than or equal to 0. And then I solve for x. Divide by 2, divide by 2. So x has got to be greater than or equal to -5/2. So I can say x such that, and I put it in that notation. X such that means right there, such that x is greater than or equal to -5/2. All right, let's do this next one here. F of x is 1 over x. Let's talk about this one. Well, I cannot, when I have a rational function here, so I have a numerator, denominator, if you will. This denominator, we can't divide by 0. So when I'm doing my domain for this, I just say x cannot be 0 in this case. So how you write that is x such that x is an element of the reals. In other words, it can be anything except 0. This means element of, and this means real numbers. Another way to say your domain here is all real numbers except x cannot be 0. That's what this is saying. It's the same thing. It can be anything except 0. Let's do this last one here. We've got f of x equals 3 over x minus 5. Well, another rational function. In other words, we've got numerator, denominator. We know we can't divide by 0, so our domain, we just say this on the bottom can't be 0. And then we solve for x. In other words, x cannot be 5. So now we say it can be anything, all real numbers, except it cannot be 5. That's our domain on this. And why? Well, if I plug 5 in, look what happens. 5 minus 5, 3 divided by, I can't do that. Can't do that. That's why it can't be 5. All right, let's keep going here. Determine which of the following relations are a function. Well, again, to be a function, the saying is for every x, there is one y. For every input, there's one output. For every input, there's one output. So, for example, I have this first one. My x is 1, my y is 2, and then I have my x is 3, my y is 4, x is 5, my y is 6. Let me put that into a mapping. So my x and my y. My 1 maps onto 2. My 3 x value maps onto 4. When I input 3, I get an output 4. When I input 5, I output 6. So now what I say is I use this saying. For every x, for this x, looks like there's one y. Now for this x of 3, looks like there's one y. And finally, for this x, there's one y. So this is okay. So this, yes, is a function. Yes, it's a function. Let's do the next one below. 1, 2, and 3, 2. 1, 2, 3, 2. Now for this x of 1, it maps onto 2. There's the first point. And then for the next one, 3 maps onto 2. And let's check it. For this x, there's one y. And then for this x of 3, there's one y. So this, yes, is a function. Yes, is a function. All right, let's do this next one here. 1, 2, and 1, 3. Let me erase some of this so I have a little room. Now we're checking the third one here, 1, 2, 1, 3. So I have an x of 1, it maps onto 2, and then an x of 1 maps onto 3. Now look at this. I have an x value of 1, but there's 2 outputs for y, so this is not a function. Because again, for every x, there can be only one y. So when you see that repeated x going to different y values, that's a problem. That's not going to be a function. So this is not a function. Now, algebraically, for that fourth one, y equals x squared plus 1. Let me erase this real quick. Y equals x squared plus 1. So here, if you notice, if I plug anything in for x, it's only going to spit out one y value. Okay, so this will, yes, be a function. Same thing for this one, x plus 5. It doesn't matter what x I plug in, I'm only going to get one y value. So this one, yes, will be a function. But if you notice the very last one, I have x squared plus y squared equals 9. Now think about this one for a minute. Let's say I throw in like, I don't know, 2 for x. So now I have 5 equals y squared. Let me write it this way. Y squared equals 5. Well, when I square root both sides, I get a plus or minus root 5. So I plugged in 2 for x, and I got 2 things for y. I got root 5, and I got negative root 5. So this is not a function. And the way that you can tell without doing all the algebra is if you have y to an even power, so y to an even power, it will not be a function. Because when you solve it for y, anytime you solve it for y, so I got 9 minus x squared, and I square root both sides, now I'm going to have plus or minus. So for whatever x value I plug in, I got 2 y values. So again, anytime you get y to an even power, it's not going to be a function. Let me give you another example. Let's say you got y to the 4th plus x equals 3. See the y to the 4th, y to an even power? This is not going to be a function. You'll have more than one y value for one input, all right? So that's it for this section. That should get you started. See you next time.